Hey guys, I came across a pretty cool model that I thought I'd share. Um, Great. So this model is about an arms race between two nation states. Um, in the literature, it's called the Richardson's model. But basically, what this model reduces to is it reduces to basically a linear equation or a linear system, dynamic system, where we have two nation states armaments values. So X is one nation state's armament, and Y is another nation state's armament. And let me finish writing this down. And so what's interesting about this model, so plus beta, okay, so where X and Y denote the armament of the two nations. At some time t. And how I'm envisioning this is, arms aren't developed continuously necessarily in real life, but they could be developed at a rate that could be considered continuous if you're looking at more of a macro view, just like let's say fluid dynamics. You're not going to consider every particle of fluid that runs through your pipe. You're going to consider the whole thing um, as a continuous system. So this model, what this model shows, a couple things. I'll make sure I don't lose that. Okay. That the arms of each nation state is negatively proportional to its own armament, or to its own armament, and positively proportional to the armament of the other nation state. So what this is saying, if we look back up at these equations, is that the armament of nation X is negatively proportional to, is this? Yeah, there we go. So the armament of nation state X is negatively proportional to its own armaments. So basically, if there's no external input into the system, the armaments of the own nation would decrease over time. However, if nation Y starts building up its own armaments, then nation X would counter that by building up also its own armaments and increasing those. So that's why that there's these inputs there. And then alpha and beta are essentially what they're modeling is the level of friction or the level of input into their own armaments. So if alpha is 0, then there's no input. If alpha is positive, then there's a positive input into the armaments of each nation. However, what we can assume, let's back up right there. So, however, what we can assume, so let's assume that the, say, quote unquote, improved relations between these two states nations can decrease the arms race, and the worsening of their relations may increase it. So what this effectively does is it augments this system here. And what we can do here is we can say, so if we let this variable u denote a measure of the goodness, quote unquote, of the relations of the two nations, then what this system essentially essentially reduces down to is, make sure that I'm on the right page, is the following. So basically what we can do is if we denote little x as equal to y and x, then this system is we can write it in terms of just linear system, minus b, a, c, minus d, x of t plus alpha, beta, u of t. So we've effectively taken this principle of in social engineering and political science, this model that they've developed, and brought it into the modeled it in such a way that we can start talking about it using control theoretical tools. Okay, so now what we want to do here is we want to talk about the stability of the system. Is it stable? So let's do that. So this system here has, this system has a characteristic polynomial given by, okay? And remember the characteristic polynomial is equal to I lambda minus a and the determinant of that. So we're going to call this, right. So this is going to be equal to lambda minus b, a, c, lambda minus d. Oops. And it's going to be the determinant of that. So let's move this guy over. So this guy is equal to lambda minus b times lambda minus d minus ac. Okay, so this gives us the characteristic polynomial lambda squared minus lambda b minus lambda d plus bd minus ac. Okay, so this guy is equal to lambda squared minus b plus d lambda plus bd minus ac. So as we saw in the lecture notes, if we want this system to have a specific eigenvalue, that amounts to forcing. So as an aside, if we want a system to have eigenvalues lambda 1 and lambda 2, that amounts to looking at the case where we have a characteristic polynomial equal to this. Lambda 1, oops, this will be minus lambda 1 plus lambda 2 plus lambda 1, lambda 2. So what we can do is if we have if this is the case, if lambda 1 and lambda 2 are the eigenvalues, then to make sure that this equation here conforms with this equation here, which would basically be figuring out what B, D, A, and C are to get this equation. Then we get that lambda 1 plus lambda 2 is equal to negative B plus D make sure I'm doing this right. Minus is equal to B plus D. Ah, I see. This should be plus and plus. This will be plus. Great. So now that's why this is a minus. All right. Then we get the second is lambda 1, lambda 2 is equal to minus AC plus BD. Okay, so this implies, which implies that both eigenvalues have negative real parts if and only if B plus D and negative AC plus BD are positive. So what this means is that if the variables, or if the parameters of our system, A, B, C, and D, which again define how rapidly the nations are either increasing their arms or decreasing their arms, depending on the specific parameter. If it's the case where, then the result here is if and only if, so it's bidirectional, if and only if AC is less than BD, the system is asymptotically stable. So basically, what this says, what this implies is that if this is true, then since A and C show how the armament levels are increasing, and BD show how they decrease, then if the product of B and D is greater than the product of A and C, that means that they're decreasing their armaments faster than they're increasing their armaments due to each other's effects. Okay, so if we look back at this equation, B and D are how the nation states are decreasing their armaments relative to each other, with respect to each other, and A and C are how they're increasing their armaments with relative threat to each other. Then if B and D are the product of B and D are greater than the product of A and C, we can show that the origin, or the case where nobody has any armaments, for U equal to 0, is the case. Is asymptotically stable. I just thought that was a pretty cool, pretty unique model to show, and how you can use control theoretical tools to actually talk about how social dynamics or political dynamics may change with inputs, or how the systems might be stable. Now, if this is not true, so now if A and C and B and D, due to the fact that this is an if and only if statement, so it's bidirectional. So if this is not true, then and there's no change in these parameters, then this is not asymptotically stable. Not so it'll explode, or it is just stable. If I believe that if A and C and B and D are equal, then this would be a stable harmonic oscillator. So it would continuously, there would be no decrease nor increase in their armaments. It would just be the same cyclic armament levels. And then if A and C and B is larger than B and D, then you have an explosion of states, and then it grows unbounded. So that's all I have. Thanks.